Now, good morning and welcome everyone to today's lecture. This is heat transfer lecture number 2. Just to give you a quick recap of what we had done in the previous class. What we had done. Now you can speak up. Tell me what we had done in the previous class. We had seen something known as temperature gradient, d theta by dl or dt by dl.
Indian house experiment.
Which one?
Indian house experiment.
Yeah. Let us understand the important point. This is known as the temperature gradient. Yes or no? Do we remember this temperature gradient? And this is also equal to theta 1 minus theta 2 divided by L. And this is constant. This is constant when the conduction or the heat flow is in a steady state. Do we remember this? When we talk about steady state, the temperature gradient is constant. Do we recollect this?
Sure.
Okay. The second thing that we saw was the heat flow dq by dt, where t stands for time, dq by dt. You can also write it as delta q, amount of heat flown divided by delta t, how much time it has flown, is equal to k a by L into theta 1 minus theta 2. Do we recollect this? Yes or no?
Sir.
We can also write it as k a multiplied by d theta by dl. This d theta by dl or theta 1 minus theta 2 by L is nothing but your temperature gradient. Do we understand this?
Yes, sir.
That's it, sir. So in steady state, the heat flow or the rate of heat flow is constant. Now, how do I begin today's class? I ended yesterday's class by giving you example of or something where we had seen the ratio of thermal conductivity to electrical conductivity is a constant at a given temperature. Do we recollect that? So I told you that heat thermal conductivity is similar to electrical conductivity, and this heat, the flow of heat, is now going to be related to something we already know, and this term that comes here, dq by dt or delta q by delta t, rate of heat flow, this is nothing but the rate of heat flow or the rate at which heat is flowing, rate of heat flow. Now, instead of calling it as rate of heat flow, I will also call it as a new name, and this new name is heat current. This new name is heat current. So delta Q by delta T or dQ by dt, which is the rate at which heat is flowing in conduction, can also be called as heat current. Do we understand this? This is also known as heat current. Heat current. Heat current. Can I have some raise hand that we understand this?
Yes,
Great.
sir.
I'll give you a minute to note this down. Please note it down. Now let us move further ahead. We have seen that, or we have called this dq by dt as your heat current, or will not probably call it the rate of heat flow. We will definitely call it as heat current. Now I have used this term current. Now as soon as this term current comes, we always think about electric current. Now let us try to make sense. Why have I called heat as current? Now let us try to make sense. And how are we going to make sense? We are going to make sense by relating the different terms that come here to the terms that we probably already studied. The first term that comes here is K. Do we understand what is this K? Do we know what is the meaning or what is the name of this word, this letter K here in thermal conductivity or thermal conductance or conduction? Tell me, what is the meaning of K? What does K tell us? It is known as, what is K known as?
Conductivity.
It is known as the coefficient of thermal conductivity. Yes, or in short, I can call it thermal conductivity of the material of the body. Yes or no?
Yes, sir.
And it has some unit, it has some dimension. I leave it to you to understand it. Now, this thermal conductivity, which is telling us what? It is telling us that how conductive a body is or how much it will conduct. It is telling us the conductivity of the body. When I say conductivity, I basically mean, is it a good conductor of heat or is it not a good conductor of heat? Do we understand this? Now, this thermal conductivity is doing the same job as sigma, which was electrical conductivity. Do we remember this term, electrical conductivity? Electrical conductivity tells us what? Tells us what? Electrical conductivity tells us what? Tell me. Electrical conductivity tells us what? Do you remember the term electrical conductivity, bacha? Do we remember the term electrical conductivity? In electric current, you would have gone across this term electrical conductivity. Do we remember this term electrical conductivity? Yes or no?
Resistance.
Yes, it is somehow connected to resistance. Do we remember this? No. Okay. ठीक है, चलो. There was a term electrical conductivity. I can't tell you the entire thing about electrical conductivity, otherwise I'll be telling you in short whatever is required. Now, if I introduce one more term here and I take the inverse of this, so what will I call it? I call it, let us say, gamma. Gamma is 1 by K, so it is the reciprocal of conductivity. If it is the reciprocal of conductivity, reciprocal of conductivity, I will call it as thermal what? Thermal resistivity. Do we understand? Thermal resistivity. And this thermal resistivity is same as what? Is same as your rho. Rho was 1 by sigma and this rho was known as electrical conductivity. Do we understand this?
Yes, sir.
So K is doing the same job as sigma, and gamma, which is 1 by K. We don't use gamma in conduction, but we can make a term gamma, which is known as the thermal resistivity. Is doing the same job as rho, which is, I have written electrical conductivity, it is electrical resistivity. Slip of tongue, electrical resistivity. Now, as soon as you think about electrical resistivity or conductivity, the next thing that comes to your mind is the resistance of the, oops, wrong color. Why am I using wrong colors? The next thing that comes to you is the resistance of the resistor. Do you remember this term, resistance of the resistor? R, ohm. Do we remember this?
Yes, sir.
Now, if I ask you the formula of ohm, I mean, not ohm. If I ask you the formula of resistance of a resistor, you will give me this formula, rho L by A. Do we remember this formula now? Does it ring any bell?
Sir.
Yes. So this is the formula you remember. Now you can also write this formula, and I hope everyone is writing because this is not in your sheet. I hope you can also write this formula in this form, L by sigma A, where sigma is the electrical conductivity. Can I have some raised hand? Do we understand this? Now I will give you a minute to think. This is electrical resistivity. I can also make a term which is RTH, thermal resistance. I can make a term called RTH. RTH is thermal resistance. TH standing for thermal, R standing for resistance. Now, can you tell me what would be the formula for thermal resistance? Looking at what is there on the right hand side. What would be the formula for thermal resistance? If you can make it out, you'll always remember it and you will never get puzzled. What will be the formula for thermal resistance? If I can create a term like this, what would be the formula for that? Tell me. If you remember, here L was the length of the resistor or length of the conductor,
Okay.
and A was the area of cross section. I'll give you a minute to think about it. A minute, think about it and tell me the formula. So tell me, what is the formula of thermal resistance? It is not such a tough question that you can't give me the answer. What will be the formula for thermal resistance? Tell me. Should not take so long. The formula for thermal resistance would be gamma. Again, I am using wrong color. I've become color blind, I think. The formula for thermal resistance would be gamma L by A. Now, in this chapter, we might not be using this formula. Instead of using this formula, I'll be using the other one, and that other one will be L divided by Ka. Do we understand this? Thermal resistance becomes L divided by Ka, whereas your electrical resistance was L divided by sigma A. Do we understand this?
Yes, sir.
I'll give you a minute to note this down. Okay, that's good that you have completed this. Now, why are we doing this? Why are we equating the terms that we are studying here in conduction to the terms that we had studied in electric current? Because we want to relate thermal current with electrical current. Now, how am I going to relate this? The right side of the table, if I just make it a table with a red line, the right side of the table are terms which we have studied in electric current. The left side of the table in black is the term that we are going to study now. Now, let us start. Since we know electric current first, so we will start with the right column first. In electric current, we had the term electric current, yes or no? And electric current was denoted by the letter I. Clear?
Yes, sir.
Know this, right? Here, I have devised a new term which is heat current. And this heat current is written as dq by dt or delta q by delta t. So far, so good? Do we understand this?
Yes, sir.
Now, if I ask you, how can I make electric current flow? Or electric current is the flow of charges. The direction of electric current is the direction of flow of charges, positive charges. Positive charges always flow from higher potential to lower potential. Yes or no? Do we remember this? Now, what causes current to flow? What causes current to flow? Current flows because of difference in potential delta V or dV. Do we remember this? Difference in potential, or I can say V1 minus V2 or V2 minus V1. Yes or no?
Yes, sir.
Why does heat current flow? Why will I have heat current flow? So heat current flows because of d theta or delta theta or theta 1 minus theta 2. So basically, this heat current is flowing because of temperature difference from higher temperature to lower temperature. Similarly, this electric current was flowing because of potential difference. Do we understand the meaning? Which term is doing what here? Yes or no? Are we understanding? The job that was done by potential difference in electric current, the same job is done by temperature difference in thermal current or heat current. So d theta replaces dv, delta theta replaces delta v, and theta 1 minus theta 2 represents v1 minus v2. Do we understand this?
Yes, sir.
I hope you are noting it down because you will not find this table anywhere else. That is why you need to note it down. And I hope the hands are working on the sheet. Yes or no?
Yes, sir. You are writing.
Yes. Now I come to the point where I write Ohm's law. I hope everyone remembers Ohm's law. Electric current I is equal to delta V, change in potential or the difference in potential divided by R. Do we remember this?
Yeah.
I can write heat current in the same fashion. dq by dt, which is my heat current, will be equal to delta theta divided by R thermal. Delta theta is theta 1 minus theta 2 divided by R thermal. And remember, this R thermal is L divided by Ka. If I put the value of R thermal from here to here, what formula I would get? I would get my original formula dq by dt is equal to L divided by Ka. No, again I made a mistake. Ka divided by L multiplied by theta 1 minus theta 2. Do we all understand how I have replaced
Yes, sir.
Ka by L by R thermal? Do we understand this?
Sir.
I'll give you a minute to note this down. Then let's move forward. So now we understand how electric current and heat current are related to each other. Can I have some raised hands from everyone that you understand this? Girls? Okay. So this is how heat current and electric current can be related. Now I'll show you how it is written in words. I mean in language. I'll show you a screenshot of your sheet, and this is how things go. Thermal resistance RTH, I call it RTH so that I don't confuse it. Thermal resistance RTH is the measure of the opposition of the rate of heat of flow or heat current. Electrical resistance is the measurement of opposition of flow of electric current. This is the measurement of opposition of flow of heat current, and it is given by L divided by Ka. Is it clear to all? And this is how you will write it. It's a very important point that you must understand. I'll give you a minute to note down the Please don't note it out in the sheet. You will have to write it with your own hands because this is very, very important.
Done, sir.
You noted it down? Well, then comes this important thing. Heat flow through slabs in series. Do we see here two slabs? This is slab number 1 and this is slab number 2. Do we see this on your big screens?
Yes, sir.
The slab number 1 has thermal conductivity K1, length L1. The slab L2 has thermal conductivity K2 and length L2. The area of cross section of both of these is same and it is taken as A. Do we see this?
Yes, sir.
Now, when these slabs are in series, you can see the same heat current will flow through them. Do you see this? dq by dt, they have written it as q by t. Same heat current flows through this. Do we see this?
Yes,
Yes
sir.
or no? No, yes. Do we see same heat current flowing through the slabs? Yes or no?
Yes, sir.
Yes, sir. Does it remind you of something that you have already seen, bacha? Do you remember these two resistors when they were connected in series? R1 and R2, when they were connected in series, you had the same current flowing through them. Do we remember this?
Yes, sir.
And we had found out that these two resistance can be replaced by a single resistance. Yes or no?
Yes, sir.
And the equivalent resistance R equivalent was equal to R1 plus R2. Do we remember this, bacha?
Yes, sir.
Right hand side, the red one is the electrical resistances in series. The left hand side is the what? Thermal resistances in this series, and the same formula applies here. Equivalent resistances R1 plus R2. Do we see this?
Yes, sir.
Now they have found out it in different ways. They have found out the value of K equivalent from the following formula, and you can write K equivalent like this for two rods. If the number of rods are more, then the formula for K equivalent becomes like this: summation of Li, that means L1 plus L2 plus L3 plus L4 plus L5, divided by summation of Li by Ki, that means L1 by K1 plus L2 by K2 plus L3 by K3 and so on. Do we understand this? We understand this?
Yes, sir.
I'll give you 2 minutes to note this down. Please note it down very carefully. Okay then. You noted this thing down? What all things you have noted down? If two slabs are in series, the equivalent resistance is R1 plus R2. I hope you have noted it down. Then you should have noted down the equivalent thermal conductivity. A question can come straight away from this. Then you must also note down that the heat current in this slabs is same. Do we understand this? You have noted this down?
Yes, sir.
This temperature T naught is the temperature of the interface. When I say interface, it means the boundary of the two slabs. This T naught is the temperature of the interface. Have you noted this down? I hope you have noted this down. Yes or no?
Repeated, sir.
Heat current is same. Resistance, equivalent resistance is R1 plus R2. We have done. We have done. We have done series. Now what is the next thing that will come? What is the next thing that will come? Tell me. We have done series. What is the next thing that will come? The next thing that will come will be slabs in parallel. They have different conductivities K1 and K2. Do you see this?
Yes, sir.
But they have the same length L. Do you see this? They can have different lengths as well, but here they have made it the length same. They have different cross-sectional area A1 and A2. Do we understand this?
Yes, sir.
Now, the question is, does the same heat current flow through them? The answer is no. The same heat current will not flow through them. The total heat current is Q by T or delta Q by delta T. How much heat current flows in upper wala? Red one is delta Q1 by delta T. I hope everyone is noting it down. Whatever heat current flows in the lower rod is delta Q2 by delta T. Are we noting it down? Yes or no? If I add these two, delta Q1 by delta T, if I add it with delta Q2 by delta T, I will get delta total Q by T. So remember this, I am writing it here. Delta Q by T, the total current, delta Q by delta T will be equal to delta Q1 by delta T, which is the heat current in upper wala rod, plus delta Q2 by delta T. I will need raise of hands from all of you to show solidarity that we have understood this. Everyone. Also, we need to remember same thing we had done in electric current. Here in electric current, we had two parallel branches. Here in electric current, we had two parallel branches. Total current flowing was I. ऊपर वाला branch it was R1 resistance. नीचे वाला branch it was R2 resistance. I1 current was flowing here. I2 current was flowing here. Do we remember this? Total current I was equal to I1 plus I2, which is same as delta Q1 by delta T plus delta Q2 by delta T, and we had find that equivalent resistance 1 by R equivalent was equal to 1 by R1 plus 1 by R2. Here also the same formula comes. 1 by R equivalent is 1 by R1 plus R2. Then they have found out the formula for equivalent resistance, and this formula looks like summation of Ki Ai divided by summation of Ai. That means K1 A1 plus K2 A2 plus K3 A3 and so on divided by A1 plus A2 plus A3. Do we understand this?
Yes, sir.
I'll give you a minute, 2 minutes to note this down. Please note it down, bacha. Very, very important results. Everything in the sheet should be noted down. Okay, then let's move on. We have done this. We'll be doing problems based on conduction in a moment. Let us now go through one of the last topics of this. And again, this topic, if the paper becomes very tough, then only this topic will come. So what I will do is I will just give you the formula. If this topic comes, then you should remember this formula. The heading is growth of ice on lakes. How does ice grow on lakes? You must have seen, not in your place, but in Western country, in Western countries where, and even in Kashmir, we have Dal Lake. The Dal Lake freezes. Have you seen that? Maybe in videos, you might have seen lakes freezing. Now, whenever lakes freeze, lakes never freeze from bottom to top. They always freeze from top to bottom. Do we know this? That is the first point that you will note down. Lake always freezes from top to bottom. Yes or no?
Yes, sir.
Lake always freezes from top to bottom. Why this happens? Because of anomalous expansion of water from 0 to 4 degrees Celsius. When the temperature increases or when the temperature decreases from 4 to 0 degrees Celsius, the volume of water does not decrease, the density of water does not increase, the density of water decreases, and that is why lake always freeze from top to bottom. Remember this, lake always freezes from top to bottom because of anomalous expansion of water. Please note it down. Once you have noted this down, then you shall draw. Once you have written this, then you shall look at this diagram, and this is the diagram that you are going to draw in your sheet, and then you will write the formula that I gave you. So what is there in this diagram? You can see that air outside is at a negative temperature minus -T degrees Celsius. Do we all see this? Then you have a layer of ice. Then you have beneath that layer, you have water at 0 degrees Celsius. This water is going to freeze. Initially, the level of ice or the depth of ice is x1. Do you see this? Yes or no?
Sir.
Then the final depth of ice is x2. Do you see this?
Yes, sir.
This is the diagram that you will draw, and after that I will give you a formula. The important things to note in this diagram is outside air is at -T degrees Celsius. We have x1 width of ice already there, and we want the width of the ice to become total x2. These are the three things that you will remember: x1, x2, and the outside temperature is -T. This is the diagram that you will draw. I will give you a minute to win it. Okay, when you draw on the diagram, we will resume, and now comes the formula that you must remember and note down what all things are coming in this formula. What is the time T2? T2 is the time. T2 is the time taken by the ice to grow to a width of x2. Do we understand this? T1 is the time taken by the width, the lake to freeze by an amount of x1. T2 is the amount of time taken by the lake to freeze to x2. Do we understand this? Can I have some reason that we understand this? T1 and T2. T1 is the time taken by the lake to freeze to x1. T2 is the time taken by the lake to freeze to x2. Half is half. Rho is the density of ice. L is the latent heat of ice. Latent heat of ice. K is the thermal conductivity of ice. No one is going to ask you the entire formula. T is the outside temperature. X2 and X1 we already know. You just need to remember this short trick, that this temperature, not this temperature, this time taken, T2 minus T1 is the time taken to go from X1 to X2. Do we understand this?
Yes, sir.
This T is nothing but the time taken for the ice layer to grow from x1 to x2. This time taken to grow from x1 to 2x2 is proportional to x2 square minus x1 square. Do we understand this?
Yes, sir.
Please note this down. As soon as you note this down, the next thing that you will understand is this formula. All the questions that you will see of growth of ice on lakes will be covered in this formula. The ratio, time taken to double, time taken to triple. How much will it be? T1 is to T2 is to T3. To double, to make it one time, it will be 1 square. To make it twice, it will be 2 square. To make it thrice, it will be 3 square. The ratio of time will be 1 is to 4 is to 9 because it is proportional to square. So if I have 2 centimeter of ice and to make it from 2 to 4, the time taken will be 4 times. Do we understand this? If I take 5 seconds to grow the layer to 2 centimeters, it will take 5 into 4, 20 seconds to make the layer from 2 centimeter to 4 centimeter. Do we understand this? To double the layer, the time will be 4 times. To triple the layer, time will be 9 times. To make it 4 times, the time will be 16 times. Do we understand this? Yes or no? No or yes?
Yes, sir.
I will give you a minute to note this down. Then let's move ahead. We have done almost everything that we had to do in theory. And now we come to the main part, which I love the most. And that part is definitely solving some questions. So let us start solving some questions. These questions are basically based on the topic of conduction. And I start with the first one. This is the first one. Under steady state, what happens? A, B, C, D, 1, 2, 3, 4. Which option is correct? Can I have your answers, please?
B.
Under steady state, the temperature of the body increases with time, decreases with time, does not change with time, and it's same as all the points of the body, does not change with time, but is different at different points of the body. And the answer is
B.
1, 2, 3, 4. Which one? A, B, C, D.
B.
B. And my dear friend, you have got -5. Congratulations. The answer is D. And if you don't remember it, well, as I always tell you, you have got short-term memory loss. And that is very bad for your profession because you would be leaving a lot of utensils in the belly of your patients and you will become a potential life threat. Steady state, if you don't remember steady state, please go back and see what you had written about steady state. Can someone read what we had written about steady state from the notes? Please go back. You can go back in time because we have short-term memory loss. So we'll go back in time and we'll see what do we mean by steady state. Anyone tell me? What is steady state? Anyone tell me? What happens in steady state? Short-term memory loss is a very dangerous sign for you guys. And you have this habit of losing the track of time, and you lose what you have studied, and this is pretty dangerous, bacha. If you become doctors, if and when you become doctors, please let me know in which hospitals you are employed, because I will never go to that hospital, because I know that my students are there and they have got short-term memory loss. They will lose something in my belly. So just to recollect your memories and make you a better Amir Khan, not the one who loses his memory in a while. These are the points about steady state. Do you remember the first point that I wrote? Can anyone read it for me now? Read it. Is there anyone in the class who can read it? English is the language probably in which you are going to attempt the paper, if I'm not wrong. Probably English is the medium there in which you are going to attempt the paper, and whatever I've written is in English only, not in Hindi. Can anyone read this?
Temperature of different
Yes, please read it.
temperature of different section would be different, but their values will be constant.
Yes, temperature of different section under steady state would be different, but their values would be constant. And I don't think that any one of you have written this in your sheet, because apart from suffering from short-term memory loss, you also suffer from long-term no writing syndrome, that we don't write anything, we know everything. And that is a very dangerous syndrome as well, because it has far-reaching effects. And I hope that my sarcasm and my comments are going in the right direction, and that you are going to learn something out of it. Yes or no? Yes or no? No or yes?
Yes,
I
sir.
hope you understand that, if you don't remember simple things in life, things are going to be very tough. Do we understand this, bacha? Yes or no?
Yes, sir.
If you can't recollect what was told to you in the last class, that was yesterday, your exam is going to happen sometime in June or July, if I'm not mistaken. You would hardly recollect anything that we had discussed in the class, and all this hard work that you are putting in and I am putting in will go to waste. Please don't do this, beta. Okay, I'll give you a time. I'll give you one chance to redeem yourself. And this is your chance to redeem yourself. Which of the following cylindrical rods will conduct most heat when their ends are maintained at the same steady temperature? So I've got 4 rods. Let's see who gives me the correct answer. They are made up of the same material. Their ends are at the same temperature. Which rod will conduct most heat?
Sir, option D. D for doctor.
D for doctor, and that is correct. So you have redeemed yourself. You have redeemed yourself in a very tough question. Tougher. And the question that I asked you in the very beginning was the easiest one of the lot, bacha. You really I really get disappointed. Okay, why number 4? Why number 4? That is the next question. Why number 4? Tell me. Why number 4? We are not playing Kaun Banega Crorepati, that you guess and you win and you move ahead. Why number 4? What is the reason for number 4?
The conduction of temperature, the length of the rod increases. Temperature in the rod.
Huh?
Temperature in the rod.
Not very satisfying answer. Again, remember, God, the Almighty God, is there to help you all. And it is that God that has helped you in giving this answer. But that Almighty God might not be so merciful that He stays with you in the examination hall. He's there with you in the examination hall, but He'll only give you that much what you deserve. The reason for this is the resistance of the rod. Now, look at, my dear friends. Resistance of the rod is L divided by Ka. Do we understand this?
Yes, sir.
Whatever rod has more resistance, it will give you, will it conduct more or will it conduct less? It will conduct less. Yes or no?
Yes, sir.
You just have to find out which rod has the most resistance. If this formula gives you trouble, then instead of using this formula for resistance, because it is ulta formula, you can use the Sida formula. And what is the Sida formula? The Sida formula is like this. If I talk about heat current, delta Q by delta T, it is equal to K. K is constant here. theta 1 minus theta 2. It is also constant here. So I can write it as dq by dt is proportional to cross-sectional area divided by length. Do we understand this? This is another way of doing the same thing. Heat current is proportional to A by L if rods are of the same material and if the temperature is same. Do we understand this?
Yes, sir.
Now we just have to find out the ratio of area to length. Remember, area is pi r square. So you just find the ratio of area to length. Here the area is 1 square divided by 1. Here the area is 1 square divided by 2. Here the area is 2 square divided by 2. And here the area is 2 square divided by 1. Which is the larger number? 1 divided by 1 or 1 divided by 4 or 2 divided by 4 divided by 2 or 4 divided by 1? And the answer is D. This is how you get the answer as D. Do we understand, my dear friends?
Yes, sir.
Will you remember this? I don't see any one of you writing. Everyone is having a jolly good time. If you don't write this, you will forget this beta. How I can recollect all this? Because I have been teaching for a long time. That is how I can recollect this. But you, as kids who are doing it for the first time, should note it down. That's a piece of advice that please write it down. I hope you are doing it. Shall I move on to the next question?
Yes, sir.
Okay. Here is the next one. And remember, the question when it comes in your exam, they might not tell you whether the rods are in series or the rods are in parallel, and that is why it is advisable for you to remember all these formulae. Here is a question from AIPMT, which is NEET 2003. Consider a compound slab of two different materials having equal thickness. Thickness is equal, and thermal conductivity is K and 2K respectively. What is the equivalent thermal conductivity of the slab? Your time begins now. I'll give you a minute. Okay. So how do I solve this? Well, it's not given whether they are in series or whether they are in parallel. If they are in series, the length L will come. Yes or no? Now, nothing has been said about the length. So I'll have to assume that these rods are in parallel. Do we understand this? So I'll assume that these rods are in parallel and I'll solve my question depending on that the rods are parallel. So if I use the formula for rods in parallel, what was the formula for rods in parallel? Do we remember that formula?
K1 A1 plus K2 A2 by
K1 A1 plus K2 A2 divided by A1 plus A2. They are given of equal thickness, so I'll assume that the cross-sectional area is also same. So it will be K1 is K into cross-sectional area A plus K2 is 2K into cross-sectional area A divided by area A plus area A. That is the answer that I will get, and that answer will be 3 by 2. It is none of the options. So that is why my answer is not matching. This is the answer that I get in parallel connection. This is the answer that I will write. I can also find out the answer for series connection. What was the answer for the series connection? Can you tell me? Here again, for series connection, I'll assume that the length is same. What was the formula for series connection? Can you tell me that formula? This was for parallel connection. What was the formula for series connection? Summation of L divided by summation of L by K. Yes or no? Do we remember that formula? Summation of L divided by summation of K. Do we remember that formula? If I use that formula, that answer will become L plus L divided by L by K. So L by K plus L by 2K. Do we understand which formula I've used here? Yes or no? Which is formula number 1 and which is formula number 2? Do we understand this? Can I have some raised hands? Formula number 1 is for parallel connection. Formula number 2 is for series connection. And when I look at formula number 2 and solve it, what is the answer that I will get? The answer that I will get will be 4 by 3K. Do we understand this? So this question was basically based on the series connection. Can I have some raised hand that we understand this? I have told you both the ways of doing this. Series connection and parallel connection. If this question was given for parallel connection also, this is how it could have been done. Done, done. Do we understand this?
Yes, sir.
Okay, now here comes another question. And this question will get you into AIMS. So let us see who is going to AIMS and who is not going to AIMS. Question comes here. Question number 29. On a cold morning, a metal surface will feel colder to touch than a wooden surface because 1, 2, 3, 4, A, B, C, D. Question number 29 from your sheet. Let's see who gives me this one.
B, sir.
The answer is B. It has high thermal conductivity. So as soon as you touch it, it will conduct your heat. And that is why the answer is B. Do we understand this? Can I have some raise hand that we understand this? Great. Great. And now we have this. Another question. And let us see. And you can see the questions that are there, they might not require a lot of calculation. They are pretty straightforward, and this one comes into light, which is question number 36 from your sheet. The two ends of a rod of length L and a uniform cross-section area is kept at temperatures T1 and T2. The rate of heat transfer through the rod in a steady state. The different formulas are given, and it should not take less than 5 seconds for you to tell me the answer. Which is the answer? A, B, C, D.
A.
The answer is A. That would have given you 4 marks. You can see the questions are pretty damn simple. And if you can just keep your morals high and remember things that we have done in the class, beta, we are putting in a lot of effort and a lot of time and obviously a lot of money of your parents in this class. Please utilize it. This is the next one in line. Let's see. As you can see, questions are repeated multiple times in different exams. And that is what we are expecting. And that is what is going to happen. The coefficient of thermal conductivity depends on A, B, C, D. We have 4 options.
Material of plate. B.
And the correct option is?
D.
The correct option is D, which is it depends on the material. Coefficient of thermal conductivity K does not depend on the area of the rod. It does not depend on the length of the rod. It only depends on the material of the rod. If this question would have been on what all factor resistance depends on, so the formula of resistance is L by Ka. It is directly proportional to length, inversely proportional to area, and inversely proportional to thermal conductivity. Can I have some raised hand that tells me that we have understood this question? Yes or no? Great. Questions are pretty damn simple. Let's see if you can do this one. Most of the questions are oral questions. They don't require calculation. They are just based on your knowledge. Question number 41. The layers of atmosphere, different layers of atmosphere. The temperatures are different. As you go higher up, temperature decreases. The layers of atmosphere are heated through A, B, C, D, convection, conduction, radiation. 2 and 3 both. And the answer is?
A.
And the answer is A. It is heated by the process of convection. Hotter air goes up, colder air goes down. All these things should be remembered. Let us see who gives me this. This is the question from IIT. Let us see if you can do this. A slab consists of two parallel layers of copper and brass of the same thickness and having thermal conductivity in the ratio 1:4. If the free space of brass is at 100 degrees Celsius and that of copper, okay, they want to ask you the temperature of the interface, we'll do it afterwards. It might require some calculation, so let us not do it here. We will do it later on. And instead of doing this one, it is better that we do this one, which has got a higher probability of coming. So I will shift my attention here to this question. These are the type of questions that are more likely to come, not the interface one. Okay, this one. If two metal plates of equal thickness, oops, you can't see this. So I'll have to make some adjustments, and I have made these adjustments here. Okay, I hope you can see this now. You can see this. If two metal plates of equal thickness and thermal conductivity is K1 and K2 are pushed together face to face, and a common plate is constructed, what is the equivalent thermal conductivity of this plate? K1, K2. What is the equivalent thermal conductivity of this plate? Can I have your answers, please? How are they put? Are they in series or are they in parallel?
Series, sir. In the series.
They are in series. So now can you tell me the answer? They are in series. Put the formula for series. Summation of L, both lengths are same, L plus L divided by L by K plus L by K1 plus L by K2, and you will have your answer. And what is the answer?
K1 K2 by K1 plus K2.
A, B, C, D. Which one, beta?
B.
C.
Sir, Bhagwan.
B for Bhagwan. Bhagwan has come to help you. That is the correct answer, beta. As you can see, if you just remember simple things in life, the same questions are going to get repeated. I keep on telling you this. I keep on telling you this. I keep on telling you this because this is what is going to happen. Next one. These are the type of questions that are going to come. Two metal rods, 1 and 2 of the same length and have same temperature difference between their ends. What do you understand by this? They have the same length and they have the same temperature difference between their ends. Are they in series or are they in parallel? Are they in series or are they in parallel, bacha? Are they in series or are they in parallel?
Parallel.
Same temperature difference. That means it's not a question of series and parallel here. They want the same rate of heat flow. Same heat should flow. Temperature difference is same. Length is same. Areas are different and thermal conductivity is different. I'll give you a minute to think about this question so that you can give me a correct answer. Okay, let us do it again. When the temperature difference is same, the rods are in parallel. Can you note this down, Betty? Beta? Note it down. When the temperature difference is same, the rods are in parallel, and I will just show you a glimpse of what we had done. I will just show you the diagram once again. If I missed this point, I should not have. I should have told you that, and I will now elaborate it. So I am going back to the diagram that I had drawn, and I hope you can see this diagram, bacha. You can see this diagram, yes or no?
Sir.
Now these two rods are in parallel. Do we understand this?
Yes, sir.
The temperature of this end, the blue end is T1. Do we understand this?
Sir.
The temperature of this end, the red end, is T2. Do we understand this, bacha?
Sir.
We understand this?
Sir.
Please note it down that in parallel connection, the temperature difference between the two rods is same, but the heat currents are different. This is what you will note down. In parallel connection, I will just write it. Maybe it is. I'll give you 1 minute first to draw what is there in the diagram. Can you see this, bacha? The screen, my screen. Remember, in series connection, and you will note this down. In series connection, what happens? It is written in blue. Number 1, heat current dq by dt is same. Number 2, temperature difference delta theta is different. Do we understand this, bacha? Raise hands will give me more confidence. In series, heat current is same and temperature difference are different. In parallel, which is written in black, we do the opposite of this. What do I mean the opposite of this? Number 1, heat current in both the rods, the dq by dt, heat current is different. Number 2, temperature difference delta theta is same. Is the point clear to everyone?
Sir.
Can I have some raise hand that tells me this? Okay, great. Now let us come back to the question. I hope you have noted this down. Now the question might not have anything to do with this, might not have, but yeah, it is somehow related to the series and parallel connection. And now I get your attention to the question that we were talking about, and here it comes on your screen right now. I'll just resize the screen so that you can see the entirety, and the question comes here. Now again, in the new light, can you now tell me the answer for this? Two metal rods, 1 and 2 of the same length, have the same temperature difference between their ends. The thermal conductivity is K1 and K2. Cross section area is A1 and A2. What is required condition for the same rate of heat conduction? When I say same rate of heat conduction, I mean the same current. I'll give you again a minute to think about it.
B, sir.
Yes, the answer is B. And how did you get the answer as B? Remember, it might not have anything to do with series or parallel connection. It just has got everything to do with how heat current flows. And if you remember how heat current flows, dq by dt is equal to K A by L, Ka by L into theta 1 minus theta 2. Do we all remember this formula? Yes or no? Do we all remember this formula? Yes or no? Raise hands will let me know.
Yes, sir.
Now here, as you can see, the temperature is same. So this cuts away. The length is same. So this cuts away. So basically my heat current is proportional to K multiplied by A. I want same heat current in both the rods. They might be in parallel. I want the same heat current in both the rods. Heat current is now proportional to K into A, and therefore the correct option is option number B. Do we understand this? So basically, what is the moral of the story? Every question that is coming on heat current or conduction is simply based on this formula. If you understand this formula, you should be able to crack the question. Yes or no? No or yes?
Yes, sir.
Can I move further ahead in life?
Yes, sir.
Okay, I get my life ahead. And let us see which is the next question. Is which one? And I think this is the next question again. As you can see, most of the questions are based on your power of remembrance. You must have to remember a lot of things, the name of lot of medicines, prescriptions, injections, processes.
Radiation.
And the answer is radiation. That is correct. Radiation is the fastest mode of heat transfer because it is electromagnetic wave. It travels with the speed of light. It is almost instantaneous. Good one, this one. Good one, this one. This is again based on your past knowledge. I have already told you this one. Let's see who gives me this one. Pyrometer or pyrometry. I told you that. Is what of these?
Measurement of high temperature.
Yes, beta?
Measurement of high temperature.
Measurement of high temperature. That is absolutely correct. You'll have to remember a lot of things. If you can remember those things correctly, you will have a pretty good time. In the examination hall. Now let us see if you can tell me this one again. If you remember what I had discussed, you should have a cakewalk here. If a liquid is heated in weightlessness, liquid is heated in weightlessness, there is no density, there is no atmosphere, there is no gravity. If a liquid is heated in weightlessness, the heat will be transferred through number one, conduction, convection, radiation.
That D.
Yes, the liquid cannot be heated in weightlessness if there is no weight, no mass. So nothing, no process will work. If you have to heat the liquid in weightlessness, probably it can only be heated by the process of radiation, or on surface you cannot heat it in any other way. Do we understand this?
Yes, sir.
Good. Let us see which is the Next one. And let's see if you can tell me the answer for this one. I would be pretty happy if you can do this. I'll give you a minute to solve this question. The length and the radius of two rods made up of same material are in the ratio 1:2 and 2:3. If the temperature difference between the ends of the rods is same, then in steady state, the amount of heat flowing will be in what ratio? I'll give you a minute to win it. I will do it. So we have to find out the ratio of heat flow. Ratio of heat flow dq by dt. The ratio of heat flow dq by dt is equal to K A by L into theta 1 minus theta 2. Now temperature difference is same, so I cut this off. Same material, so I cut this off. So now my heat current is proportional to A by L. Can I have raised hands from everyone? A by L. So you just have to find the ratio of A by L. So heat current 1, let me call it as I1. I1 by I2, ratio of heat current I1 by I2 will be equal to A1 by L1, A1 by L1 divided by A2 by L2. So it will become multiplied by L2 divided by A2. Do we understand this? So basically I can write it like this. It is A1 by A2 multiplied by L2 by L1. Do we understand this? A1 by A2 multiplied by A1 by A2 multiplied by L2 by L1. Do we understand this? Just find the ratio and get your answer. How do I get the ratio of A1 by A2? How do I get the ratio of A1 by A2? I look at the ratio of radius. The ratio of radius or radii is 2:3. Area is radius squared. So the ratio of area will become 4 by 9. Do we understand this? The ratio of area, which is in yellow, will become 4 by 9. Now let us now work on to the ratio of lengths. L2 by L1 is in blue. Look at the blue one, lengths. Lengths are in the ratio 1:2. So L1 by L2 is 1:2. I have to find out L2 by L1. I have to find out L2 by L1. I have to find out L2 by L1. So it will be equal to 2 divided by 1. Do we understand this, bacha? It was simple question of ratio. Now it is very easy to see the ratio, and your answer, the correct answer would be option C, and that is 8 by 9 is the answer for this question. Shall I repeat this, or have you understood this? Heat current dq by dt is Ka by L into theta 1 minus theta 2. Same temperature difference, theta 1 minus theta 2 goes away. Same material, K goes away. So my heat current becomes proportional to A by L. Heat current of 1 divided by heat current of 2 becomes equal to A1 by A2 into L2 by L1. A1 by A2 is 4 by 9. L2 by L1 is 2:1. I multiply it and I get my answers. I'll give you a minute to note this down. So I move ahead with this question. I think we had done this question previously. It is a question from thermal expansion. You can see it has been repeated number of times. Again, this is just a revision question. In a solid metal sphere, there is a spherical cavity. If the solid is heated, what happens to the volume of the cavity? What happens to the volume of the cavity? A, B, C, D. Tell me the answer. 1, 2, 3, 4. Is a cavity inside a metallic sphere. You heat up the sphere, what happens to the cavity?
Volume increases.
The volume of the cavity will increase, and that is how we see it. Well then, that is the end of the class today. What we have done in today's class? In today's class is basically concentrated more on conduction and solving question on conduction. We have seen that the heat current and electric current are same. Heat current is dq by dt. Electric current is I. Heat current flows because of temperature difference. Electric current flows because of potential difference. Heat current dq by dt is difference in temperature divided by thermal resistance. Electric current is difference in potential divided by electrical resistance. Thermal resistance R is L by Ka. Electrical resistance R is L by sigma A. Both are doing the same job. We had seen slabs in series and slabs in parallel. In slabs in series, the resistance becomes R1 plus R2. The formula for thermal conductivity becomes summation of L divided by summation of L by K. Here, you must remember heat current is same, but temperature difference is different. Do we understand this? In the case of parallel, if I have two rods in parallel, the temperature difference is same, but the heat currents are different. In that case, if you want to find out, if you want to find out what? If you want to find out the equivalent resistance, 1 by equivalent resistance is 1 by R1 plus 1 by R2. If you want to find out equivalent thermal conductivity, the formula becomes summation of Ka divided by summation of A. Most of the question that we have seen was based on this formula. Dq by dt is Ka by L into theta 1 minus theta 2. In some cases, rods were same material. K was cancelling out. In some cases, area was same. In some cases, length was same. In some cases, the difference in temperature was same. So basically, in a nutshell, the entire chapter of conduction is based on a simple and single formula. And what is that simple and singular formula, bacha? What is that simple and single formula? That simple formula and singular formula is the formula which is now in red. Dq by dt, the heat current is K by L into theta 1 minus theta 2. Everything else can be done with this formula. Do we understand this? Can I have raised hand that we understand this? Now, in tomorrow's class, we'll move on to the second part of this chapter, which is radiation, where you will find most of the questions coming up from. So we will be dealing with radiation. We might take one class, it might not be over in one class. We will have to take at least two classes to finish radiation. So we'll be starting with radiation in the next class from tomorrow. Till then, take good care of yourself, study, and try to solve questions. I think I have solved almost all the questions in conduction. There are not any questions left. I have also checked it. So I have covered all the questions. Have faith. Please remember what I have told you in the class. You can watch the lectures. The lecture is recorded. You can watch the lecture again. Please make notes. I'll see you tomorrow. Take care. Have a good life. Bye-bye.